Hello, this is Mrs. Robertson, and today in Math 6 we are going to find how to do the area of composite figures. It's located on page 717 in your math books. And this is a topic we're going to spend 2 days on to make sure you really have a good grasp of how to find the area of composite figures. Now, what is a composite figure? It is a figure made of two or more two-dimensional figures. This one over here to the right, it's made up of two rectangles. Sometimes it's a rectangle and a triangle, or a parallelogram and a rectangle. Yes.
Are we looking at shapes for the rest of the year?
No, just for a couple more weeks. Probably we will stop right before spring break. So from now till about spring break, we'll be doing shapes, and then if we have time, we'll do mean, median, mode, and range before spring break. That's what I would like to be able to do. But yeah, we're going to be doing geometry during this time. Yes, Grace.
What is spring break?
Spring break, it says, draw a composite figure made of a rectangle and a triangle on the graph paper below. So on this, you can draw a triangle and a rectangle, and they have to connect. So let's do that. Yours won't look the same as mine. I am going to
Wait, so we can't do that?
No, you can do this. I'm just there. That's the one that I've drawn. Now, the math book has this one drawn. Theirs is a little different. See how they have theirs? Theirs is a trapezoid, isn't it? Mine looks like a house. This is like the garage or something over here, like a little ranch house. All right, everyone have a triangle and a rectangle picture drawn? Now, in this, it says the real world link. The dimensions of the pool are shown. So this pool is 14 feet by 28 feet, and then they add on this trapezoid. This is a trapezoid right there. So it says, what two-dimensional figures are used to make the shape of this pool? It's a rectangle and a trapezoid. So let's write that down. Rectangle and the trapezoid. Everyone sees both of those shapes? All right, it says, how could you determine the area of the pool floor? Well, you find the area of the rectangle. I'm going to abbreviate. And the trapezoid. Then add the areas together. Any questions on that? That makes sense, doesn't it? You find the area of the rectangle, find the area of the trapezoid, and add them together. Make sure you are writing this down in your book. Okay, let's turn the page and go to page 720. Or not 20, 718, excuse me. On page 718, here we have a composite shape. This is also a trapezoid, isn't it? But we already know the formula for the area of a trapezoid. Let's just write it over here. The area of a trapezoid equals height times B1 plus B2 divided by 2, right? Okay, now let's say you aren't given this formula for the area of a trapezoid, and you have this shape and you have to find the area of it. If you don't have the formula for the area of a trapezoid, or if you don't remember it, you just cut it up into two shapes. Here it's a square and a triangle. You find the area of the square, 9, area of a triangle. We like using the formula base times height divided by 2 for the area of a triangle. So the base is 2 and the height is 3. Divided by 2 is 3. And then you add the square is 9 plus the triangle, which is 3. So the area of that shape is 12. All right, now let's go on and do example 1. This is really more of a traditional composite shape. Find the area of the figure at the right. Well, let's just cut it right here. It's a rectangle and a triangle, right? The area of the rectangle, they write the formula, length times width. That's 10 times 6, which is 60. Okay, and on your paper, you have to write the formula, write what you're going to multiply, and then I will let you use a calculator. Now for a triangle, it's base times height divided by 2. 4 times 4 is 16, divided by 2 is 8. I like using this formula. It's the same thing, but I just think you're better at dividing by 2 as opposed to multiplying by a half. All right, any questions? Let's do letter A and B together. All right? Let's, how are we going to cut this shape? We could cut it several ways. You could cut it here, couldn't you? And you'd have a rectangle and a triangle. You could cut it here, and then you would have a rectangle and a trapezoid, and then you could make a big rectangle and subtract a trapezoid. Which way do you want to do it? Do you want to do a rectangle and a triangle, or a rectangle and a trapezoid? A trapezoid and a triangle? I think let's do rectangle and triangle. So let's do it this way. Okay, everyone put your dot there. Now we're going to go up to the top of our paper, and this is letter A. How are we going to do letter A? We have to find the area of a triangle equals base times height divided by 2. Okay, let's go look at our triangle. Our base is this distance from here to here. Oh no, I don't know what that is, but we can figure it out. This is 8, this is 12. What is that missing number? What's 12 minus 8? 4. This is 4. Do you see how I found the missing number? 4 plus 8 equals 12. Now, I got to figure out from here to here. From here to here is 10. From there to there is 4. So if that's 4, what's this distance here? 6. 4 plus 6 is 10. So that's a 6. So the dimensions for my triangle are 4 and 6. So now I'm going to replace it. 4 times 6, it's a triangle, divided by 2. You see that? Do you have that written on your paper? So the area equals 4 times 6 is 24, divided by 2 is 12 feet squared. Now we have to find the area of the rectangle. In letter A, that's easy. The rectangle is 12 by 4. Now when you trace the shapes, it's easier to find the numbers. So the long line is 12 by 4. And here 8 plus 4 is still 12. So 12 times 4 gives us the area of the rectangle. Rectangle equals length times width. So the area equals 12 times 4. And that equals 48. Okay? Now we're ready for our last step. In our last step, we add them together. You add the triangle plus the rectangle. So we have 12 plus 48 equals 60 feet squared. Do you see how to do the composite shapes? All right. Are we ready to do letter B? Let's look at letter B. In this problem, I see a rectangle and a triangle. I'm going to extend that. Now, it's a rectangle minus the triangle, right? And I think we can figure out the dimensions of that little triangle, can't we? So in this one, it's going to be rectangle minus triangle. Okay? So let's find the area of our rectangle. That is going to be what, kids? What am I going to multiply to get the area of the big rectangle? Trace it. 10 times 5 or 10 times 7? 10 times 7. Yeah, 5 is not the full length. So the area of the big rectangle is 10 times 7, and that equals 70 meters squared. Does everyone see that? I didn't see everyone write that down. Please write that down. Let's write it down, everyone. Now we have to find the area of the little triangle right here. That triangle. The area of my triangle is, mystery. If this is 7, how far is it from here to here? 3. 7 plus 3 is 10, right? And if this is 5, what is this going to be, Carter? 5 plus what will give you 7? 2. So the dimensions of our triangle are 2 and 3, right? So it's going to be 2 times 3, it's a triangle, divided by 2, right? 2 times 3 is 6, divided by 2 is 3 meters squared. Now, do I add those together or do I subtract them? Subtract. That was cut off and removed. So the rectangle is 70 minus the little triangle, which is 3, means the area of that shape is 67 meters squared. Do you see how we got that? Sometimes you add them and sometimes you subtract them. Now, if you're not writing this stuff down, you're not going to figure this out. Kids, this is all, when you take your math tests on Mastery Connect, here we have example 2, the swimming pool problem. This one, you find the area of the rectangle, and it's 392. Circle 392. Circle 392. Then you find the area of that trapezoid. That is 10. Circle the 10. Now, do you add these two together or do you subtract them?
No.
You add these, yeah. You take 392 plus this is 10, and the answer is 402 square feet. All right? Any questions? Now, let's just, it says do this problem. We're going to go on to example 3, and we'll do some problems like C in the guided practice in a little bit. Find the area of the figure at the right. Okay, this is what they are doing. The square is 144, 12 by 12. You see that? They get 144. You find the area of the rectangle, 15 times 12, 180. Now the sum of the areas, 144 plus 180 is 324. But they overlap, don't they? Overlapping areas. Well, we know if this is 6, 6 plus what is 12? This is 6, okay? Now, if this is 8, 8 plus what is 15? This is 7. Do you see that? Do you see how we get the unknowns? 7 plus 8 is 15. It's got to equal that line. 6 plus 6 has to equal this line, which is 12. So now we find the area of this shape. 7 times 6 is 42. That's the area that overlaps. So since it overlaps, you subtract it. All right, now we're going to do letter D, where we have an overlapping. We're going to find there are rectangles. We have two rectangles. Area of rectangle 1 and area of rectangle number 2. Okay, I'm going to put a 1 in there, a 2 there. So I'm going to say this rectangle is number 1, and it is 6 by 7. 6 times 7 is 42. Everyone agree? Feet squared. Now let's find the area of number 2. 6 by 8. 6 times 8 is 48 feet squared. Did you write it neatly like that? Now, what did they do up above? They add those two together. So let's add these two areas together. And we have 90 feet squared. Any questions on that? But it has an overlap, right? And the overlap we're going to subtract. The overlap is this shape right here. We have to find the dimensions of this shape and subtract it. Well, well. All right. This is 1. 1 plus what is 6? 1 plus what is 6, class? So put a 5 here. From here to here is 8. And I guess they're saying this is 2. 2 plus what is 8? 6. So the area of our overlapping is 6 by 5, right? So it's a rectangle. And it equals 6 times 5, and that is 30. Since it's an overlap, you subtract. 90 minus 30 is 60 feet squared. All right? Any questions on that? I will say that if you thought this, if we thought that was a 2, let's not go, we were just saying that this is a 2 when we were doing this. That 2 arrow, that was just a little confusing. If we have a question like this on the test, I'll make sure you know how long each line is so it's not as confusing as what that one is. I just thought it was a little vague. Yes?
Can you taught me 5 because there's the one also cut off right there on the edge?
Well, this one we said was 5. I thought this was a 1. It could be. If you were looking at it a different way, I could see where you would think that would be a 5 and this would be a 5, and you'd have a 25 and you'd end up with a 65. I could see how you would, I could see two different answers depending on how you interpreted. It could be 65 if you thought it was 5 by 5, but if you thought this was 2 and that was 2, I could see where it could be interpreted either way. All right. Let's go look at the next page. Example 4. I don't think we're quite ready to do the word problems. We're going to save the word problems for tomorrow. And instead of doing the guided practice, let's just turn to page 721. Today, I just want us to focus on finding just the shapes. And then we'll add word problems to it tomorrow, all right? So what do I want you to do? We're going to do page 721, and I'll do some of these with you. I want you to do number 1. Number 1, you could even see that as a trapezoid, couldn't you? Number 2. Number 3, in number 3 you have a rectangle and a trapezoid. So you'll take the big rectangle minus the trapezoid. I want you to do number 4. It's an overlap. In number 5, I think that'll be enough for today. Do 1, 2, 3, 4, and 5. I think we'll do those together. All right? I need to take attendance. Go ahead and get started on 1. If you get stuck, number 2 is pretty easy. But we'll be doing these together. And then we'll talk about anything else we need to do for today.